Nuclear magnetic moment, just like the electron that have the dipole moment, magnetic dipole moment. Similarly, here this nucleus also have the magnetic moment. This magnetic moment is due to the spin motion of the nucleons inside the nucleus. The nuclear magnetic moment is due to spin motion of nucleons inside the nucleus. So this spin motion is responsible for magnetic moment. The nuclear magnetic moment is responsible for hyperfine structure of spectral lines. We know that the atomic line spectrum has the different lines of the different wavelengths. When these are viewed in presence of electric field and the magnetic field, it is found that these are again divided into a number of lines. This is called the fine structure of the spectral line. But when we find this in presence of the nucleus and that the magnetic moment associated with this nucleus, then it is found that these fine structure is again divided into other very finest structure of the nucleus of the spectral line. That is we call the hyperfine structure of the spectral lines. As it has been told earlier that the nucleus are of three types: even nucleus, odd nucleus, even odd nucleus. What does it mean? Even nucleus means that the number of proton and neutron are even. Odd nucleus means that the number of proton and neutron are odd. And even odd means that the proton and neutron are either one of them is even or second is odd. So now we have this thing in mind. We have to this magnetic moment about this of this nucleus. So in ground state, for even nuclei, the spin and magnetic moment both are zero. It means that this magnetic moment is attributed by the unpaired nucleons. For odd nuclei, spin and magnetic moment is not equal to 0. For even odd nuclei, the spin and magnetic moment is not equal to 0. So the magnetic moment is attributed by the unpaired nucleons. Nuclear magnetic moment is due to unpaired nucleons. In case of pair, the magnetic moment due to one nucleon is cancelled by the other nucleon, but in case of odd number or the unpaired nucleons, the magnetic moment of one is not cancelled by the other, so that have the permanent magnetic moment. Nuclear magnetic moment, this mu n is equal to Gn into E upon 2 mp into I. This is the formula. So what we have that where Gn, this is equal to nuclear G factor. Nuclear G factor. I, the spin quantum number, E, the electron charge, and mp, the mass of proton. Mass of proton. So this is denoted by mu n. Proton and neutron both have magnetic moment. So this is not so that neutron is a neutral particle, so it will have no magnetic moment. This is not so, because spin motion is also is possessed by this nucleon or by this neutron. So this magnetic moment is possessed by the both the proton and the neutron. So now magnetic moment of proton, magnetic moment of proton, this mu p, that is equal to mu n. And the magnetic moment of neutron, mu n equal to minus 1.9130 mu n, where this mu n that we have written here, this is called the nuclear magneton. E h cross upon 2 mp, where this h cross equal to h upon 2 pi, and this is equal to eh upon 4 pi mp. This is equal to mu n. It is called nuclear magneton. Nuclear magneton. So this nuclear magneton is dependent upon the mass of the proton, h the Planck's constant. Planck's constant. So now it has the units of joule per Tesla. Unit joule per Tesla. This is now SI unit. SI unit. And we'll like this arcs per Gauss. Then this is now Gaussian or the CGS units. If we have this electron volt per Tesla, then this is now electron volt unit. So this can be expressed like this one. Now the value of this magnetic moment. Now as we have the dimensional dimensions M0, L2, T0, A1 ampere meter square. It's simply the ampere meter square. This is the unit of this magneton. So this ampere meter square can also be expressed as joule per Tesla. So now this is what that we have discussed about the nuclear magnetic moment. So this magnetic moment is very essential quantity to decide the nuclear resonance also, and to study the nuclear properties, and to study the hyperfine structure of the spectral lines. So this is about the nuclear magnetic moment. So thank you very much.